Hi everyone, I'm Jalal Nouri. I come from Stockholm University in Sweden, and it's a pleasure for me to be here, and I thank the committee for inviting me for having this talk in this warm and beautiful Florida. I think my body is more fit to be in this environment than in the cold Sweden. It's winter now, so I really like to be here today, and I will have a small uh, talk about learning analytics and basically introduce the field. How many of you are aware of the field of learning analytics? If you just raise the hand. A few of you, so I think this will work. For you, it will be a small repetition maybe, and some probably and hopefully some new insights as well. I'm an associate professor at the Department of Computer and System Sciences at Stockholm University, and I also lead a group that focuses on learning analytics and artificial intelligence for education. And previously, and also still, I do research on technology-enhanced learning. That's a little bit about me. So today I will give a brief introduction to the background, then I will define the concept of learning analytics and show examples of learning analytics research and provide some examples from my own research to illustrate what's going on in the field. And this talk with describing and talking about the implications for education and for future education in particular. We are in the beginning of an historic and unique transition. They call it many times the fourth industrial revolution, and this revolution produces really quick and deep changes across all sectors of human life, and we can't really comprehend where we're going and what is happening to full extent. But we know one thing for sure, and that is when human life is digitized, a large amount of data is produced, and this data can be used for different purposes. In other fields, such as economics and biology, psychology, they have used this data in combination with novel and powerful machine learning techniques and methods and data science methods to gain insights, identify patterns, do predictions. That was not really possible before the introduction of this type of data and the novel methods. And it is against such a background that we have seen the emergence of the field of learning analytics. It's a quite new field. The first conference was held 2011. So we are really in the beginning. And what learning scientists and computer scientists have been doing is that they have looked at the development in the other fields where they have used a lot of data and asked the question, hey, we have a lot of data in school environment as well. We use digital learning management systems. We use different applications. We have digital administrative systems that produce vast amount of data. Let's do something, try to do something with that data. And this is the ambition of the field. And here you have the formal and I would say the dominating definition of the field. So it says learning analytics is the measurement, collection, analysis, and reporting of data about learners and their context for purposes of understanding and optimizing learning and the learning environments in which learning occurs. And this definition was presented 2011 in the first conference, but is still highly referred to. And when learning analytics research is conducted and conceptualized, it is often done with this figure, so we can have data on an analysis on a macro level, looking at national educational registers or national data of different kind to understand what's going on a national level, for instance, or a regional level, or you can even compare between countries and have an international analysis. Then we have the meso level, and the meso level can concern specific schools or a cluster of schools, and that type of research is done to understand the performance in general of schools. And then we have the micro level and the classroom level, where people look at the specific learners, the teachers, the specific learning environments in which learning occurs. I think this is a nice figure that Professor Barbara Watson from Slate Center in Norway presented in a systematic review paper. This is the methods that are used in the field of learning analytics. As you can see, most of them are, or all of them are, from the quantitative tradition, and we see a lot of advanced statistical methods and a lot of methods stemming from machine learning and data science. So what we can conclude here is that we have, from my perspective, I do that conclusion at least, the introduction of quite powerful tools into educational research, and we also see that computer scientists and data scientists are entering educational research more, and with a powerful toolbox that can change things, I believe. These are, and when the tools and methods are used in the field, the last 8 years, these research strands have emerged within the field, and we have a lot of predictions of performance that is conducted using often machine learning algorithms that have been shown to be superior to traditional statistical methods. And many times these methods are used to detect students at risk, and I will show example of several of these research strands later on. So, and they focus on the early detections of students at risk in order to provide them very early intervention. Many studies look at dropouts in college, in universities, etc., and try to, in a very early stage, detect them. And they do it quite successfully. Then we also have a lot of data visualization, quite novel visualizations, at least within the field of educational research and learning sciences, that have been shown to provide very good insights into learning and learning processes. We have quite a lot of work on adaptive learning environments through intelligent feedback and and through personalized learning, and this is supported by the data that is collected and the machine learning methods that are applied. We have student skill estimation, a lot of behavior detection, attempts to identify behaviors of low achievers versus high achievers in order to gain insights about, for instance, how the high achievers navigate in a digital learning environments, and these insights are then the basis of formative feedback to the low achievers. Look at, this is how the high achievers navigate and interact with each other, with the resources, you should have you should be inspired by this. So learning from the high achievers and feeding it back to the more low achievers. We have quite a lot of work that is done looking at social aspects of learning, how students collaborate and interact with each other, with the teacher, in learning management systems, but also in classrooms using sensors, because sensors have been introduced in many places around the world in classrooms. In Sweden, we have we have two big projects right now that introduce sensors in the classroom to capture different behaviors, which are used then to understand, for instance, the social aspects of learning. This is an interesting strand as well. In the beginning, the field had a quite strong focus on performance prediction and looking at the learner. Now the unit of analysis have been broadened. More and more are looking at how we can use data that is generated in, for instance, learning management systems to improve course design, to make the teacher more informed about the learning design decisions, the didactical decisions that teachers make in a certain environment. We see this more work on this strand nowadays, which is of course related to improved instructor performance, another of the research strands. And the final research strand is the multimodal learning analytics, which is also quite new. Now, in the beginning, as I said, the focus was very much on these digital learning management systems, but learning, of course, takes place beyond these systems. Most of the times we use blended learning environments. Some things happen at campus, some things in the learning environment. Flipped classroom is one quite clear example of this. And so now, once again, the unit of analysis have been broadened. We don't look only at what happens in the learning environment. We look at also the classroom environment and the transactions between these environments, because they affect each other. And sensors play a role here again, different type of sensors. So the classroom is changing. We see new technologies coming in. I will talk more about that later on. Now I will give some examples from my own research. Speaking of flipped classroom, we did a study 2018 on a course that I had on research methods. And the course was delivered through flipped classroom, so a blended learning environment. A learning management system was used. It was a Moodle-based system. I'm sure you know of Moodle. And the system captured a lot of data about when they logged in, what they clicked on, when they clicked on that, who they interacted with, how much they interacted with that person. We basically collected everything that we could and fed it into machine learning algorithms in order to predict performance of students, so we could very early on identify students at risk, because this was a quite, I don't know the scale of courses here, but for us this was a large course. We had 500 students, and when you have 500 students and a limited number of teachers, of course you can't address all that needs help. So we try to get help from technology and these machine learning algorithms. And we were able to actually, using this data, to predict performance with around 78% accuracy based on their behavior in the learning management system. Now, this is not a perfect number, but it's better than random, and what we can do with our human brains only, and it's a work in progress. So besides the prediction here, we also learned and could identify the factors that explain performance and failure. We could cluster low and high achievers in terms of the variables, and we could characterize their behaviors and see how they differed. So we learned, for instance, that we could see procrastination behavior among the low achievers, which is quite problematic, especially in a flipped classroom environment where they're supposed to look at the video lectures beforehand, before they come to the campus. So if they procrastinate, do not look at the video in time, then everything will, there will be a lot of negative consequences. So this was a quite good finding for us as teachers to know that we have a procrastination behavior among the low achievers. And this type of analysis then could be used as the basis for automatic formative feedback that is fed back to both students and teachers. Also, a very recent work that just have been submitted. We had actually two systems that had data about the bachelor thesis project at our department, and we have used these systems for around 8 years. It contains information about 2,500 bachelor thesis projects. We of course got interested in these databases and collected all the data. It was data about the students, the age of the students, their entry grades, the topics that they have chosen for the bachelor thesis, average grade during their bachelor program, etc., etc. And then we had a lot of data about the supervisors, how many bachelor thesis projects they have supervised at the department, the average time of completing a bachelor thesis project for the supervisors, the age, the position, how many, the scientific experience and scientific output of the supervisors measured in article production, accepted article production, for instance, etc. Use this as futures, as we call it. That was, and we applied machine learning algorithms in order to predict completers and non-completers of bachelor thesis projects. We have around 30% non-completers at our department. I don't know how it looks here in the US and in other countries, but for us this is of course problematic. It has individual and social negative implication, as well as of course economical implication for the department, etc. So we wanted to address this, and we could with 75% accuracy actually predict non-completion. And this again is not a perfect accuracy, but it's better than what we can do with our brains. And we could identify actually several factors that could explain thesis performance that have not been reported on early on when researchers have looked at thesis students' thesis performance. I think I don't have so much time to go through all of the examples in depth, but here is just an example of a data visualization we did looking at interactions between students and teachers, so between the students and between students and teachers, using social network analysis, and we gained a lot of insights that was acted upon. We did an intervention, gave feedback to the teacher, because the teacher was quite central in the first course. So we designed the course, got another interaction pattern, and we continue. So the data allowed us to actually improve the course design, so we could have more productive interactions between the students and the teachers. This is another example of a visualization. Here we looked at the temporal aspects of learning in a flipped classroom context. I mentioned the procrastination behavior. This was part of that study. Just an example of visualizations that can be done. Now, what is happening is that we are going towards, supported by learning analytics and this data, we are going towards more informed schools, teachers, and students. We have opportunities to get more data-informed course and curriculum design. I have the levels that I showed before in parentheses here, in the micro level here. Then we support the teachers to understand themselves better, how they act and how they instruct, based on data. We support, learning analytics support the teachers to understand the students and what's going on among them better through the data. And we help the students to understand themselves better and in order to self-regulate in a data-informed, data-grounded way. Learning analytics can also support schools to develop on a data-grounded way, and educational systems in general on a macro level. And I think this is needed because in the educational field, many call for data-grounded ways, data-informed ways of developing teaching and learning. We are many times quite alone as teachers with our own brains, subjective brains that tries to analyze the situation, make something good out of it. But data and these novel machine learning methods can support us to do this much better and to see what's not visible for us otherwise. In general then, if you look at how the EdTech, educational technology business is going, all this is going towards more adaptive learning environments, more smart environments that make good use of the data that is generated. And we also see a development towards Internet of Things in schools where sensors are introduced and where technology is interconnected and produce data that can be used for good productive analysis in schools. But there are some implications for schools and teachers and students. We need to develop competencies. The analysis and the examples I showed was done by people that had the technical know-how and understanding. We need to develop these among teachers and students, and especially three types of competencies. We need a new type of data literacy. The teachers need to be develop skills in collecting this type of data. What data is of good quality? What data should I collect? How should I collect that? Analysis, also important. How should I do the analysis? And we can help them by automating analysis in different types of software, so they don't need to write the code in Python and do machine learning themselves. I think that would be a difficult way forward. And they need to be trained in interpreting the output of the analysis and how to act on it. So here is the insight. How should I act on this type of insight? And of course, we need to develop critical thinking because, as you could see before in the examples, the algorithms produce errors and error marginals. we can't trust them fully. So when should I trust the algorithm? When should I trust myself? Or another thing. Critical thinking is quite important. And maybe most important question is the ethical aspects. How much intrusive should we be? What type of data should we collect? What type of insights should we convey to the students? Should we tell the student that she or he is predicted to be a dropout or a failure, or should we not do it and attack it in another way? A lot of questions that requires our attention. Think how much time do I have? I think that was actually the end of the